welcome to Cambridge Chemistry channel with Sarvati Ahmed. Today I will solve chemistry paper 219701 October November 2024. Let's start. Question number 1 is cobalt, rhodium and iridium are metals in the same group of the periodic table. The shorthand electronic configuration of cobalt is AR3D74S2. Identify what is meant by AR. AR is short form, and it is orgon is present in period 3. So AR is the short, this is short form electronic configuration, and AR is equal to electronic configuration of AR like up 1s2, 2s2, 2p6, 3s2, 3p6. So if we write down AR, so it means these electronic configuration is there instead of AR. So cobalt is 3d7, so then afterwards 3d7, 3 afterward 4s2 and 3d7, because cobalt is present in period 3, and after filling A or this electronic configuration we have to write down 4s2 and 3d7. The lowest energy electrons in the cobalt are in the 1s orbital. Draw a shape of 1s. So this is 1s, okay, and if we want to draw 2s, that is, this is 2s and this is 3s. So simply draw the 1s orbital like this. This is for 1s mean first period, 1 mean first period, and s is the lowest energy level. This is like this. Reduce the number of unpaired electrons in the cobalt atoms. Reduce the number of unpaired electrons in the cobalt atom. So this is the electronic configuration of cobalt atoms, and we know that in 3d orbitals we have 5 degenerate orbital. So this is 3d orbital, 1 2 3 4, 1 2 3 4 and 5, and electrons first like this unpaired, unpaired, and because 3d is 7, so then this is paired and this is paired. So reduce the number of unpaired electrons in cobalt atom. So there are 3 unpaired electrons in a cobalt atoms. So write down 3 over here. Table 1.1 gives some details of the stable naturally occurring isotopes of rhodium and iridium. Rhodium number of neutron is 58, so number of proton is 45, and total number of electron shells. So iridium, it is present in, rhodium is present in period 5, so total number of electron shells are 5. Iridium number of protons are 77, and subtract 191, 71, because this is nucleon number, and we want, if we want to find out number of neutrons, so nucleon number, uh, proton number subtracted from the nucleon number, so this is the 114. And similarly iridium 193 is 77, and neutron number is 116. Next question is about C parties table 1.2 shows the relative abundance of isotopes in a sample of an alloy containing rhodium and iridium only. So define relative isotopic mass. So it is defined as average mass of all isotopes of element compared to the mass of to the mass of 1/12th carbon atom, mass of carbon atom, 12th mass of carbon atom of C12 carbon 12 isotopes. Next, use table 1.2 to calculate the relative atomic mass of iridium in the alloy. Give your answer to two decimal place. So, average relative AR of iridium is equal to relative isotopic mass into relative abundance. Relative iridium is isotopic mass into relative abundance divided by total mass of isotopes. Abundance total abundance. So we have 190.96 into relative abundance is 15.18 plus 192.96 into relative abundance is 34.82, and if we add these two abundance we get 50. So the answer is 50.00. The answer is 192.35. Hydrated rhodium uh, 3-chloride catalyzes the conversion of ethene to butene. Both stereoisomers of butene are formed in the reaction. Hydrated rhodium 3-chloride contains 20.5% by mass of water of crystallization. 20.5 mass of water of crystallization. Deduce the integer value of X in rhodium 3-chloride dot H2O. So we have to find out X, number of water molecules in, and we know that rhodium 3 chloride are HCl3 and water. So water mass is 20.5 and subtract, because it is percent, so subtract 20.5 from 100, we get 79.5. It means rhodium 3 chloride has 79.5 mass. So the rhodium chloride, the MR of rhodium chloride is, so this is mass over, this is AR, sorry, MR, AR, sorry, MR, and this is 209.4, and MR of water is 18. So calculate mole. So mole is 0.0